Welcome to today's lecture on cloud computing and storage. We will be covering key topics such as virtualization, software-defined compute, cloud compute services, and different types of storage.
Part 1: Cloud Compute.
Virtualization or containerization recap. Let's start with a quick recap of virtualization and containerization. Virtualization involves using hypervisors to create virtual machines (VMs) on top of hardware. There are two types. Type 1, bare metal hypervisors that run directly on the hardware. Type 2, hosted hypervisors that run on top of an existing operating system. Containerization is different as it uses the host OS and shares the kernel, but isolates applications through containers.
Software-defined compute. Software-defined compute abstracts compute functions from hardware, allowing pooling and distribution across multiple processing units. This approach uses generic and industry-standard hardware, making it easier to scale resources.
Cloud compute services. We have several major cloud providers offering compute services. Amazon EC2, AWS Virtual Machines, build per second. Azure VM, Microsoft's offering build per minute.
Types of compute instances. Instances can be categorized into several types depending on the workload. General purpose, compute optimized, memory optimized, storage optimized, accelerated computing, burstable instances.
Tenancy and purchasing options. Instances can be deployed in different tenancy models: default or shared, dedicated instances, dedicated hosts. Various purchasing options exist: on-demand instances, reserved instances, spot instances, savings plan.
Instance lifecycle and placement groups. The lifecycle of instances includes creation, running, stopping, and termination. Placement groups allow better control over the physical placement of instances for optimized performance.
Part 2: Cloud Storage. Software-defined storage. Software-defined storage, SDS, abstracts data storage resources from underlying hardware, providing more flexibility and scalability.
CAP theorem. The CAP theorem states that in a distributed data store, you can only have 2 out of 3 guarantees: consistency, availability, and partition tolerance. Types of storage. Cloud storage is categorized into 3 main types. Block storage manages data in blocks, suitable for structured data like databases. Examples include AWS Elastic Block Storage and Azure Disks. File storage manages data as a file hierarchy, typically used over shared networks. Examples include AWS Elastic File System and Azure Files. Object storage manages data as objects consisting of data, metadata, and a unique identifier. Examples include AWS S3 and Azure Blobs.
Object storage features. Object storage comes with several advanced features. First, one versioning. Second, one encryption, including client-side, server-side, and various key management options. Third, one web hosting. Fourth, one immutability, including time-based retention and legal hold.
Storage tiers. Cloud providers offer different storage tiers for various use cases. AWS offers standard, intelligent tiering, infrequent access, Glacier. Azure offer hot-cold archive.
Other important aspects of cloud storage: archiving and backup, important for data retention and recovery. Hybrid storage combines on-premise and cloud storage. Bulk data transfer, services to move large amounts of data efficiently.
Today we covered the fundamental concepts of cloud compute and storage. Understanding these basics is crucial as they form the backbone of modern cloud-based applications. In the next lecture we will discuss about cloud networking.